If we're going to convert just a regular fraction to a decimal, just divide. Divide the numerator by the denominator. Now, a lot of calculators these days will actually convert a fraction to a decimal and a decimal to a fraction for you. But how would you even enter a repeating decimal? Okay, let's work our way up to that. If we want to divide 3/4 out to a decimal, that means 3 divided by 4. So in your calculator, you would enter 3 divided by 4. If you were going to do it by longhand, if you didn't have a calculator with you, let's look way, way back. Remember 4th grade? 4 won't go into 3. So I want to bring the decimal straight up. So 4 into 30. 4 into 30 would be 7. 7 times 4 is 28. Subtract gives us 20. Bring down the 0 here. 4 into 20 goes 5 times. 5 times 4 is 20. No remainder, we're done. What about 2/3? If we didn't have a calculator and we didn't know what it was? You probably know that 2/3 is going to be 0.66666 forever. It's 2 divided by 3. Now, when you put that in your calculator, you're going to get 0.6666, and when it gets done, when it gets down to the last digit it shows in the window, it's going to round that to 7. That is not exactly what 2/3 is. 2/3 written exactly is 0.66 forever. And we indicate that the forever goes on, that the 6 is repeated by, at some point, putting a line over the last 6, or you could do the last 2 or the last 3. You could simply write this as 0.6 with 1 6 and 1 line would be sufficient. If we divide this out by hand, notice that this is 2 divided by 3. So 2 divided by 3, 3 won't go into 2. So there's our decimal point. Put a 0. 3 goes into 20 6 times. 6 times 3 is 18. Subtract gives us a 2. Bring down a 0. 3 goes into 20 6 times. 6 times 3 is 18. Subtract, we get 2. Bring down a 0. Okay, you should be able to see that this is going to go on forever and ever. So once you see what's going on, you just put a line over that. It's going to be 6 forever and ever. So any rational number, any fraction, can be converted to a decimal by doing the top number, the numerator, divided by the bottom number, the denominator. And it's either going to terminate, or once you see that it's set into a forever pattern, you can just draw a line over the digit or digits that are going to be repeated forever. What do we do with a decimal that if it never repeats, you're kind of stuck? That's an irrational number. But if it is a rational number, it's either going to terminate or it's going to follow into a repeating pattern. So to convert okay, here's to go back the other way. To convert a terminating decimal to a fraction, just rewrite it as a fraction. 0.5 is the same thing as 5/10. So that written as a fraction is 5/10. And when you reduce the fraction, you get the 1/2. Make sure you reduce it. Fractions have to be simplified when you put them in as answers. And my math lab is completely unforgiving in this. So no matter how many steps you went through to end up with 5/10 as the answer to a problem, if you leave it as 5/10, my math lab will count it wrong. It's a computer, it can't think, and you can't win an argument with something that can't think. So make sure you reduce your fractions. If it was 0.52, that is the same thing as 52 hundredths. 2 decimal places, 100 with a TH, hundredths. So that's 52 over 100. which would reduce to, let's see, 26 over 50, which would be 13 over 25, and that's as far as that's going to go. And likewise, 0.127. Now you see the pattern is that you're going to have one more zero than you do, well, the same number of zeros as you have decimal places. So this would be a 127 over a 1 followed by 3 zeros. And honestly, I don't think that's going to reduce at all. So that's done. 127 would divide by, won't divide by 3, obviously won't divide by 2, won't divide by 5. I don't think it would divide by 7. Let's see, that would be 550, no. Won't divide by 11, no. 13, 9 times 13, 27, carry the 2, 11, 17, no. And so we're almost up to 127. That's not going to reduce. But what if it were a repeating decimal we'd been given and told to rewrite as a fraction? Like, say, 0.4 forever. 0.4 with a line over it is not 4/10, it's 0.4444 forever. Now, there's a trick to doing this. However many decimal places you have in the repeating portion, you multiply, take the power of 10 that has the same number as the number of repeating decimals, and multiply this number by that. In other words, this has one repeating decimal. So if I take 0.4 forever, and I multiply it by 10, that's going to move the decimal over one place so that I get 0.444 forever. If I multiplied 0.4 times 100, 0.4 repeating times 100, multiplying by 100 just moves the decimal place over two places. So that would be 44.4444 forever. So you can write this as 0.44, a 0.4 dot 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 if you want. So if I take this, the 0.44444 dot dot dot, and I multiply by 10, now I get 4.44444 dot dot dot. Now if I get the difference between these two, if I take 4.444 forever, and I subtract the 0.444 forever, I would have 4. However, notice that this is 10 times 0.4 forever minus 1 times 0.4 forever, which would leave 9 times 0.4 forever. Let me show you that again. 10 times 0.44 forever minus 1 times 0.44 forever leaves me 9 times 0.44 forever, right? So I've got 10 of those minus 1 of those leaves 9 of those. So 4 equals 9 times 0.4444 forever. If I divide by 9, then I get that 4/9 equals 0.444 forever. So 0.444 forever is equal to the fraction 4/9. let's try that again. If I had 0.32, where the 32 was repeated forever. So this is 0.32, 32, 32, 32 forever. If I multiply this by 100 to move the decimal over 2 places, 100 times 0.323232 forever is going to equal, that moves the decimal over 2 places. So this is 32, 32, 32, 32 forever. So if I take 100 times 32, 32, ... minus 1 times 32, ... I'm going to get 99 times 0.3232, ... 100 of these minus 1 of these leaves me 99 of these. So 32.3232 ... minus 0.3232 ... Since all of these digits are going to line up forever, this leaves 32. So 9 times 0.323232 forever is equal to 32, and 0.3232 forever is equal to 32 over 99. Let's try one. Try 0.666 forever. You can write 0.66 ... Only one digit repeats, so you only need to multiply it by 10. Try it. Stop the video and try it yourself. Okay, you got it? If I do 10 times 0.666 forever, which is going to be 6.666 forever. And then I subtract 1 times 0.66 forever, which is just 0.66 forever. The difference is 6. 10 of them minus 9 of them minus 1 of them is 9 of them. So when I divide both sides by 9, I get 0.6666 forever is equal to 6 over 9 is equal to 2 over 3, 2/3. What happens if the repeating digits don't instantly start as soon as you cross the decimal point? What if I had 1, 2, 3, 4, 5, 6, 5, 6, and the 5, 6 repeated forever? Take the number of digits that actually are in the repeating pattern and multiply by that power of 10. In other words, we got 2 digits, so we're going to multiply by 10 squared. We're going to multiply by 100. So 100 times 1.245656 forever minus 1 times 1.245656 forever will equal 99 1.245656 forevers. If I multiply by 100, This will move the decimal place over 2 places. So this becomes 124.5656 forever. Got it? Minus 1.2456 forever. We know this is the part repeating, so these are going to line up. So this is going to become the fall of 5, 6 cancel. So I've got a 2, 3, 3, 1, 2. So 99 of these is equal to 123.32. So 1.2456 forevers is equal to 123.32 over 99. However, you cannot ever leave a decimal point in a fraction. So I'm going to have to fix this further by multiplying top and bottom by 100. So this is 123.32. Okay, 12,332 over a 99 and 2 zeros, so 990,000. And now I have to reduce this. Well, let's see. These will actually divide by 4. So dividing by 4 here is going to give me 3, 3, 3, 3. Dividing this by 4. Is 2475. Okay, this is larger than 1, but then this was larger than 1 too, so that makes sense. Let's see. These will both divide by 3, which would be 1111 over 2475 divided by 3, 8, 2, 5, 825. Let's see, this will divide by 5, but that won't. I'm going to assume this is probably as far as it'll go. Let us cheat. If I had 1111 divided by 825, I get something different. Okay, back up. I made my mistake when I was reducing right here. 123.32 divided by 4 is 3083. 9,900 divided by 4 is 2475. I can double check this by saying 3083 divided by 2475 equals that's the original. Of course, it had to round off, but that's it. And would that reduce any farther? Now, I couldn't put the original repeating decimal in. I don't even know how to do that. Nothing that goes into 2475 will also go into 3083. So this is the simplified fraction. Of course, that wasn't a very simple one, but it shows that you can actually do anything this way. So that's how you do it. You multiply it by the power of 10, where the power is the number of repeating digits. You take that minus one of them, which will give you 9 or 99 or 999 or 9,999 if you've got 4 repeating decimals. Multiply it out, subtract, divide both sides by this number, and that's going to become your denominator. And then reduce, simplify the resulting fraction. If it's still got decimal places in it, multiply numerator and denominator by enough of a power of 10 to get rid of your decimals, and then proceed to go through and reduce that fraction. That's not real easy, but you're not going to get a whole lot of those. Okay, so have fun with this. You might want to show it to somebody to show you know this great trick, and we'll talk to you later. Bye.